The purpose of LRO is to provide data and information to safely go back to the moon. And our experience in the past, this includes Apollo, but it's also true of the Martian landers, where we've done the same kind of work there, is that a lander is built in such a way with an assumption that when it lands, there are going to be rocks underneath, and it can only take a certain size of rock. And the ones on the Mars landers, for example, I think if there was a 30-centimeter rock, which is about 1 foot, and it landed on top of it, it would be just okay. All right. So they're interested to know how high these rocks are to see whether, in fact, a particular area is safe to land. Because if you have a roughness, as we call it, of rocks of 3 or 4 feet, there's no way a lander can get down there. LOLA is a laser altimeter. It sends a short pulse of light from the spacecraft. It is then split into 5 separate pulses. So actually 5 pulses go down to the surface, hit the surface, come back again, and come to 5 different detectors on the spacecraft, and hence derive the distance of the surface below the spacecraft. And we do this about 140 times per second. In addition to the altimetric measurement, which is the distance measurement to the surface, we measure something we call this pulse spreading, which is the fact that the laser pulse that goes out is shaped rather like a pulse, a Gaussian curve. That pulse goes to the surface, and because of the surface features, it gets distorted. It gets spread, as we call it. If it's like a sheet of ice, or let's say water or glass, there will be no spreading of the pulse. If in fact it's all got rocks and lumps and bumps on it, then the pulse will come back spread. And although we don't know exactly the distribution of the rocks or the bumps, we can say approximately what the spread of the heights, if you like, within that 5-meter spot are. It was not easy to do this instrument as quickly as we needed to. We knew approximately what they would need, and so myself and colleagues got together and sat down and thought about the stringent requirements that clearly were going to come along for this mission in terms of, say, an altimeter. And we, like most of these things, you have a hiccup along the way at least once or twice, but we have a great instrument team, and they worked very hard, weekends as well, trying to get this thing together. So right now, the instrument's on the spacecraft, and it's beautiful, it's spectacular.